All right, so today we are working with section 4.4, working with addition and subtraction with fractions. Now, I'm going to make this distinction early on to separate these things out or make this abundantly clear. To add or subtract any two or more fractions together, they must have the same denominator. It's also referred to as like denominators or common denominators, anything like that. So I think we had it yesterday when we were going through the 4.1 and 4.2 material. Someone had thrown out the thought of, well, I need to make sure that these two fractions have the same denominator to multiply them together. And again, with addition and subtraction, we absolutely must have the same denominator. For multiplication or division with fractions, we don't care if the denominators are the same or different. I want to make that distinction as clear as I possibly can of the same denominator is only applicable to addition and subtraction. That's it. So we're going to work with two scenarios, I think a little less common one first, but we are adding or subtracting with like denominators. I mean, these things have the exact same denominator from the very beginning. And if we do have that scenario showing up, we're saying, okay, well, this requirement that we have at the top here has been met. So fantastic. What do we do from there? Well, all we're going to do is we're just going to be adding or subtracting the numerators together as if they were whole numbers. And we're just going to have a single resulting fraction after that. When we are adding or subtracting fractions together, we are only adding or subtracting the numerators. The denominator is going to stay the exact same while we're adding those things on the top together. Once we've added the 1, the 2, 3, 4, however many fractions we have, all into a single fraction, always make sure you fully reduce the result that you get. Going back to 4.1 if we need a reminder on that. And this is also going to be a part that's, because we're going to have fractions on this next test, always leave your answer as a fully reduced fraction. I will absolutely take off points if I'm seeing something that it's most of the way done, but it's not fully reduced. I'm taking off points for that. So this is an overarching rule for this entire chapter and for all fractions moving forward. Fully reduce the resulting fraction that you get. So we're going to take a look at our two examples that we have here. Again, a bit more straightforward. We'll go into more advanced ones down here where I'll actually work this out. But if we're told, okay, simplify each of the following. So our first equation, or expression, I should say, we have 8 over 9 plus 16 over 9. Now in this scenario, we always need to say, okay, I'm adding fractions together. Is the denominator the exact same? In this case, yes, both of them are 9. So our requirement for all of these has been met, so we're good there. And what are we doing from there? Well, I'm just going to add or subtract the numerators together to create a single resulting fraction. So only adding the numerator. 8 plus 16 is going to give me 24. The denominator stays the exact same during this step where I'm adding and combining fractions together. So that's going to give me 24 over 9. Fantastic. It's now a single fraction. I say, can I reduce this thing down at all? We have to if we can. The greatest common factor between 24 and 9 is 3, so I can cancel that out from the numerator and denominator and get a resulting fraction of 8/3. Looking at our other example, we have 1/4 plus 13/4 minus 2/4. So you can go about this, and I condensed the steps down in how I typed it up, but you could add the 1/4 and the 13/4 together. That's going to give you 14/4. Minus 2/4, so 14/4 minus 2/4. It's going to give us 12/4, just like we have right here. And then we're saying, can I reduce this thing down any further? 12 divided by 4, that is 3. And we have our answer right there. So these are the scenarios that we will ultimately want to get our fractions into. The same denominator, and then just add the numerators together and fully reduce down. Okay? So we get into the more common scenario now. It does require some extra work, but we're going to go into this one. So I'm going to zoom this in here just a little bit. It's a little small. There we go. All right, so when we are adding or subtracting with different denominators, and again, this is the more common scenario that we're going to see on the homework, on the test, and all of the future math classes. This is the more common setup that we have. So our requirement stays the same. If I want to add or subtract these fractions together, I need the denominators to be identical to one another. So we're going to need to find the lowest common denominator to make that happen. Now you might read in the textbook or from other resources that say this thing is referred to as the lowest common multiple of the denominators, and that's another accurate statement. So you're either going to see it listed as the lowest common denominator or the lowest common multiple of the denominators. And really it's the exact same thing, just two ways of saying it. So to clarify that, I'm going to go with our definition of what multiples are. So multiples of a number d are basically taking a number and counting by that farther on up we get. So it's 1 times d, 2 times d, 3 times d, 4 times, 5 times, etc. Again, multiples of that number. So if we were to list the, making up a couple here off the top of my head here, if we were going to list the multiples of 2, we would have 2, 4, 6, 8, 10, 12, and so on. So you're taking the original number that you have, multiply it by 1, then by 2, then by 3, then by 4, and so on. If we I'll use another example here. If we were to list the multiples of 5, it would be 5, 10, 15, 20, 25, 30, etc., etc. So that's how we could find and list the multiples of a number. But if we're trying to find the lowest common denominator, or the lowest common multiple of the denominators, this is the main thing that we're going to end up having to look for. And we want to find what is the smallest number that is divisible by each of the denominators of the given fractions. And the reason we want to choose the lowest is, well, do we really want to be working with thousands, millions, billions in our numerator and denominator? Probably not if we can help it. So that's why we try and find the lowest one, so it's going to be bigger numbers, but not as big as they could be, where it becomes even more of a pain to reduce things down. And I do have a hint or a little bit of a trick to find this that I do have mentioned in here in our process. And I'll go through and show you guys what that looks like, because I think it's a really great shortcut, but that's just my personal opinion. I'll at least show you guys all the same. So we kind of have some of our definitions that we have here and what we're looking for. So now we're going to go into the actual process if we're going to add or subtract with different denominators. So first and foremost, the first thing that we need to do is determine the lowest common denominator of all the fractions. You absolutely must do this step. There's no getting around this. So there's a couple ways that you can go about making this happen. You can list off the multiples of all the numbers and then find the smallest one they have in common. Some people just like counting up from the biggest number, which is kind of what we're going to do, but there's different ways of organizing that for yourself. And again, whatever works best for you to organize finding that, do it. Once we have found that lowest common denominator, we're going to create equivalent fractions of each of the originals so they all have that lowest common denominator from step 1 as their denominator. So essentially I'm trying to find what's the smallest thing I can convert all of these into for a denominator. I'm going to rewrite all of them to have that lowest common denominator. And once we've done that, we have met the requirement that we need to add or subtract fractions. Same denominator. Once we've done that, we're just going to add or subtract the numerators together to create a single fraction. And again, when I am adding or subtracting a fraction, only the numerators add or subtract together. The denominator stays the exact same in that entire addition-subtraction process. Once we have everything as a single fraction, always look to fully reduce that fraction down to its lowest terms, just like we did in 4.1, like we did a little bit in 4.2, and just as a generality, what we want to do with all of our fractions that we're working with. So the hint that I have for you guys finding this lowest common denominator, I would recommend using the multiples of the largest denominator, and then check to see if the other numbers will evenly divide into those multiples. This can save you a lot of time. So I'm going to jump on over to the whiteboard. I am going to be referencing these examples when I'm going through problems, but I do want to touch base on what I mean by using this suggested method for finding the lowest common denominator. So we'll jump on over there, and I'll show you guys what I mean with that. Okay. So again, I'm going to try and link these two ideas together. Remember, the lowest common denominator is the same as saying the lowest common multiple of the denominators. So I want to show you guys that kind of trick that I mentioned of finding the multiples of the largest number and then finding the lowest common multiple from there. I just want to give that to you guys because I think it's very, very useful, and it's very, very handy to have on your side as you're going through these. So let's say, taking a quick step back from the actual examples, and I want to find the lowest common multiple of the numbers 2, 3, where's the one that I had, and 10. Okay. So one of the ways you could go about finding the lowest common multiple between these, start with the original numbers, and then we're just going to list out multiples of each of those numbers. Always start with that number times 1, and then that number times 2, and then times 3, and times 4, and so on. So starting with 2, the multiples of 2, 2, 4, 6. You can kind of see where our pattern is going here. And now the main question that I get asked a lot is, okay, so I'm listing all these out. When do I know I'm going to have a lowest common multiple with these other numbers? And really, if we're using this method, you're just going to list things out until all 3 numbers have something in common. So we'll go with 3. So we'll go 3, 6, 9, 12, and so on. So we're probably seeing a few instances already between our numbers. Oh, there's some similarities between those. Okay, yeah, and you're probably seeing some of those in 2 and 3 where they match up, and that's great. But again, we're trying to find the lowest common multiple of all 3 numbers that we have been given. So I'm going to start listing out the 10s. So again, 10 times 1, 10 times 2, 3, 4, etc. So as we're looking through this, we're seeing of all the multiples of 2, I'm seeing that we have 6s in common with 3s. I see that we have a 2 in common with a 10. I'll use this, use a spotlight here. We have these 6s in common, but it doesn't work with the 10, so can't do that. We have 10s in common, but it's not the same as the 3. So I'm not seeing anything that is the exact same with all the numbers that I have listed. And if we are going to go through and use this method to find a lowest common multiple, then we need to keep listing numbers out. I'm going to do this by listing out more of the 2s. And now I'm seeing I do have a common multiple, and specifically a lowest common multiple between all 3 numbers, and it's 30. So the lowest common multiple of these 3 numbers is going to be 30. And again, you might be seeing that, well, I've got 6s laying up here, I've got 10s laying up here, and so on as we have some of these. But again, we are trying to find the smallest number that all 3 of these numbers, lowest multiple that all 3 of these numbers evenly go into. So as we're seeing this, we're saying, okay, so here's one way of going about finding that value. And you're welcome to do this. I think it's very time intensive and it takes a while to do. but you are welcome to do that if you'd like to. Now the other method that I'm going to show you guys, I think this one's a bit faster. And this is that hint. Call it the hint method because I wrote that into the notes that way. So same idea. We're trying to find the lowest common multiple of, we had 2, 3, and 10. So this method that we have is a little bit different, and there's a kind of a different way of organizing it compared to the other two. So if you were going to use this method, identify what is the biggest number that you are working with. In this case, biggest number is going to be 10. That's going to be essentially your main variable that you're using for this. What we're going to do is we're going to set up a table for ourselves. Put the largest number on the leftmost side, and then list each of the other two numbers on the right. And now we're going to list on the left column the multiples of 10. Let's say, first off, starting with 10. We ask ourselves now, does 2 evenly divide into 10? Yes, so it works for 2. Does 3 evenly divide into 10? No, it doesn't. So I can't use it. Move on to the next one, okay? Next multiple of 10 is 20. Can 2 go into that? Yes. Can 3 go into that? No. So I can't use that number. Does 30 work for both of these? Well, does 2 go into 30? Yes, it does. Does 3 go into 30? Yes, it does. I have just found my lowest common multiple. Because the left-hand column tells us, well, 10 goes into all of these numbers, so that's taken care of for us. And then all we're doing is doing a quick check in each of these other columns to see, is it a multiple of those other two numbers? And if it is, bam, we're done. We have our lowest common multiple. So all this method is just an alternate way of finding that. I think it's a bit faster, in my opinion, mostly because you don't have to worry about listing tons and tons of numbers like you would have to otherwise. So again, do that little bit of setup for yourself, a little bit of organization, and then it could save you some time and some headache on that front. Okay? I'm going to move us over here, and we're going to actually work with the examples from the lecture notes now. And I'm going to utilize that, that method that we just did to go through and solve some of these things as well. So our first example that we had, shown up on the other page, just in the lecture notes, we had 1/2 plus 5/6 minus 4/9. So again, following our process, just as it's written out, I'm reading off the notes on a different screen, so that's where these methods are coming from. So we need to determine the lowest common multiple of all the fractions. So again, you can use the method that we used on the left, where the first method where we're listing out multiples of all of the numbers and just going until we find something. Or we can use the second method, which is the one I'm going to use, to determine what's the lowest common multiple of these three numbers. You might also be someone who you're looking at 2, 6, and 9. You're saying, well, I already know what the lowest common denominator is going to be between those. And if you're in that boat, great. It's fantastic. I'm going to go through and show the more in-depth method only because I think it's worth seeing it applied in an actual problem like this. So following the second method that we did for finding that lowest common multiple, making a table for myself, I'm going to have 9 top left. I'm listing the others. I'm saying, what's the first multiple of 9? Well, it's 9 times 1. Does 2 go into 9? No. 6 doesn't, so I can't use that. The next multiple of 9 is 18. Saying, okay, well, 2 goes into 18, and so does 6. So I've just found my lowest common multiple. Use red here. So our lowest common multiple, or lowest common denominator, again, kind of interchangeable. I had to make a triangle. Can't I? Ugh. What's it doing to me? I don't know why it's doing this. Actually, no, I do know. There we go. Okay. Now that we got that taken care of. So our lowest common denominator between these is going to be 18. So now I need to go through and I need to rewrite each of these fractions to have that lowest common denominator. So again, I am creating an equivalent fraction. I am not changing the values of what they're, or changing the fractions entirely. I'm just changing the way that they are written out. So I'm going to take this 1/2, and if multiply numerator and denominator by 9, so that's going to make the denominator 18. I don't care what the numerator is, but I want the denominator to be 18. Multiplying the middle fraction by 3/3. And then the last fraction by 2/2. So with all of these, I'm just writing out my process for creating an equivalent fraction. All of these are going to have a lowest, or they're going to have a denominator of 18. So I can add or subtract them together. So multiply each of these straight across. I'm going to get 9/18 plus 15/18 minus 8/18. So now everything has a common denominator, and now I can add or subtract the numerators together. So I'm going to work with the first two of them first, just going left to right. 9/18 plus 15/18, so give me 24/18. I still have that minus 8/18. And then I combine those together. 24 minus 8 is going to give me 16/18. So now I have everything as a single fraction. Can I reduce this down? Yes, I can. I'm going to get 8/9. We have our final answer there. So again, be very methodical as you are going through and rewriting fractions, adding or subtracting fractions together. And remember that it's only the numerators that are adding or subtracting and changing in value once we get to our, once we have the lowest common denominators for this. Okay. I am going to step out here for a quick minute, and then I'll come back and we'll get going on a second example, or maybe go through a couple more if necessary. Okay, so working with, right out the other example that we had here from our notes. So we have 5/3 minus 11/12 minus 1/4. Okay. So again, we're working with an instance where we do not have a common denominator, and we need to figure out what that is going to be. So again, I'm going to go through the extra step process we've showing you guys using this other method. I want to find the lowest common denominator between 3, 12, and 4. So again, it's a method that I find to be really helpful for me. It's really fast. It's a lot faster, I think, than listing things out, or listing everything out for all the numbers. So starting with 12, I'm saying, does 3 evenly divide into 12? Yes, it does. Does 4 evenly divide into 12? Yes, it does. So we've got our lowest common denominator right there, which is nice. So now I need to go through and create equivalent fractions of each of our originals so that they have a denominator of 12 so I can add these things together. So I have 5/3 and I want to convert that to have that denominator of 12, so I need to multiply top and bottom by 4. The middle fraction, well, it already has that denominator of 12 written in on it, which is great. So it's one less thing that we need to actually convert over, and we can leave it exactly as it is. Move on to the last fraction. I want that denominator to be 12, so I need to multiply the bottom by 3, and subsequently multiply the top by 3, because again, I'm creating an equivalent fraction. Multiplying everything together, we're getting 20 over 12 minus 11 over 12 and minus 3 over 12. So now everything has the same denominator. Now I can add or subtract the numerators together. I'm just going to work with the first two fractions first. So 20 over 12 minus 11 over 12, that's going to give me 9 over 12. And now combine these together. We have 9 minus 3, that's going to give us 6 over 12. Now everything is a single fraction. Can I reduce this down at all? Yes, I can. 6 evenly goes into both of these numbers, and I get 1/2 as the final answer. Okay. So zoom us out here a little bit. So the method for finding the lowest common denominator that I use for both of these with this table, you're welcome to use it if you'd like to. You don't have to use it if you can find out what these lowest common denominators are in your head. If you can do that, great. If you would like to go with the method that we started with of just listing everything out for yourself, you're welcome to do that. I would just have a lot of scratch paper nearby, maybe a whiteboard or something if you're going to do that, because it's going to take a long time to find those, potentially. And then otherwise, once we've found that number, again, we're just following that step-by-step process in the lecture notes to go through and solve this thing. And always make sure you are fully reducing your fraction down fully reducing your final answer down if it is a fraction. If you don't do that, you're going to lose points on the homework, you're going to lose points on the test. Always make that thing fully reduced if you can. Okay? So that is our lecture notes for section 4.4. I'm going to end the recording, and then if you guys have any questions, we'll go through those.